LC, Ops 1, Vic indicates all armed and ignition enabled.
Copy, Ops 1, check 167.
LC vehicle and FTS are armed.
Copy that vehicle, check 168, ROC, send range status and alert signal and verify. And Rock LC, countdown 1, your go for step 169, send range status and alert signal and verify.
LC, Rock, range is green.
And I copy range green, check 169.
L-3 minutes and counting.
And Ops 1 LC, countdown 1, step 171, mode SIGI to nav.
LC, Ops 1, in work. LC, Ops 1, SIGI in nav mode. Time is 21:34:45.
LC vehicle, SIGI in nav mode. True heading is 120.597. SIGI is nominal and green.
Copy all vehicle, check 172. And Ops 1, your go to initiate countdown to auto sequence startup at T-minus 1 minute, 30 seconds.
LC, Ops 1, in work. LC, Ops 1, countdown initiated.
Copy that, Ops 1. T-minus 1 minute mark.
LC.
L-minus 1 minute.
Auto sequence start.
Copy, auto sequence start.
Electrical, PDUs, and ODMs enabled. Vehicle fully armed.
Copy, electrical 1. T-minus 30 seconds. Mark.
Go Minotaur C, go planet.
Stage 0 TV squibbed.
T-minus 10 seconds. Mark.
L-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff of Minotaur C carrying the SkySat and Dove satellites for planet.
Attitude is nominal. Attitude remains nominal as the Castor 120 Stage 0 motor propels the 104-foot tall Minotaur C vehicle away from Vandenberg Air Force Base. Stage 0 motor pressure is nominal. Attitude remains nominal. Stage 0 TVA is performing nominally to control the flight of the vehicle. Vehicle is past max Q. Attitude remains nominal. Now approximately 50 seconds into the Minotaur C mission for planet to place 6 SkySat and 4 Dove spacecraft into a sun-synchronous orbit. Attitude remains nominal, coming up on Stage 1 TVA pressurization. Stage 1 TVA has been pressurized. Stage 0 has burned out. Stage 0 separation. Stage 1 has ignited and attitude is nominal. Stage 1 TVA is nominal and controlling the flight of the vehicle. Power buses remain strong at 100 seconds into the mission. Now 2 minutes into the Minotaur C mission for Planet. Attitude remains nominal as the vehicle altitude passes 100 kilometers. And we have lost telemetry in the center. We have negative telemetry in the center.
STM. Yes, we still have lock on range data. Yes, so we have can work.
And ROC, this is vehicle on countdown 1. We have negative telemetry in the center here at building 836. Was just hoping you could confirm the track of the vehicle via radar.
And this is the rock.
This is vehicle on countdown 1. We have recovered telemetry in the center. We are now 230 seconds into the flight. Attitude remains nominal, and we're in Stage 2 burn. Stage 2 burnout. Vehicle energy state is good. Fairing has separated. I repeat, the fairing is confirmed to have separated and fully deployed. Vehicle is now in a prolonged coast phase as the flight software of the Minotaur C vehicle waits for the vehicle altitude to reach our orbit injection point of approximately 500 kilometers. And once again, we have negative telemetry in the center. Okay, this is vehicle on countdown 1. We have active telemetry in the center once again. Now over 300 seconds into the mission. All systems are operating nominally.
This is Minotaur Mission Control. We have had second stage motor separation. The rocket stack has now entered a 4-minute coast phase. Liftoff was at 2:37 p.m. Pacific Time. I'm joined now by Chester Gilmore, Vice President of Manufacturing for Planet. How about that launch?
That was amazing.
Yeah, great. Well, thanks for being here. Can you tell me a little bit about how the SkySats are built and who the major players are that are involved?
Yes, absolutely. The SkySats are built with a whole lot of awesome.
The major players would be obviously the tremendous efforts from the engineering team at the formerly at Terabella and Skybox team, who actually engineered the bulk of the work. And then the payloads are built by L3, and the propulsion modules are provided by ECAPS, and it's actually very interesting. It's a green propellant system on board these SkySats, and the final assembly and test integration and launch campaign is supported by SSL.
Okay, great. So can you tell us what kind of testing the SkySats undergo prior to launch?
Oh yeah, we do all the testing.
All the testing.
All the testing.
So I understand you have 4 Dove Cubesats on this launch. So how do the 2 satellite fleets complement each other?
Yes, absolutely. If you think about the real plan for the product in the future, what Planet is building is really information about the changing planet. So we think of this like a queryable Earth, where you can go to our platform to ask questions about the planet and find answers. If you think about the different classes of spacecraft, they would operate much like the human eye operates. So if you think about the human eye when it's looking at a wide field, you have your peripheral vision, which are the Dove satellites, providing a base layer of about 3 to 5 meters resolution. And then when you see something of interest, you would turn your head and your iris would zoom in and focus. And that would be what the SkySats would do. So the theory is to operate them as a homogeneous network of spacecraft.
Okay, that's really interesting. Yeah. So I understand you've launched many times in the past. So what makes this specific launch so unique?
Well, this has been a lot of fun. In the past, we've always been secondary, which means we're somewhere in the trunk of the rocket, not paid much attention. And this has been our first dedicated rocket launch, and it's actually our first time we've been involved in mission control and the launch operations. So it's been a tremendous amount of fun.
Well, that's great. Glad we can provide that opportunity for you. So tell us a little bit about the art that's on the rocket fairing.
So the art on the rocket fairing was provided by our artist in residence, Forrest Stern, and it depicts several concepts. The first is an image of a dove, which represents the Dove class spacecraft. And then in addition to that, there's an image of a macaw parrot, which is meant to illustrate the SkySats, a much larger macaw parrot. So all of the spacecraft that we've launched to date, including the Doves, have all actually had art etched onto the side panels of the satellite. So art's something that's very important to us at Planet, and we hope to continue.
That's great. So can you tell me, excuse me, how Planet's customers use your imagery?
Absolutely. So we have a very, very wide customer base. There's the traditional consumers of pixels or satellite imagery, which would be agricultural resellers or the government. And then we have a newer class of customers who are more interested in insights that they can provide out of the data. So they're not taking the geotiffs or taking the raw pixels, but they're looking for answers. And those might be hedge funds, insurance companies, people who are utilizing our platform to develop applications to do automated road detection. So a good use case of that would be after a disaster is struck. First responders could use the platform to figure out, okay, where are there actually roads still, so we know where to send aid.
Oh, that's really great. Thanks so much for being with us here today.
Absolutely, my pleasure.
Yeah.
Thank you.
Looking forward to deployment.
Absolutely, yeah. Fingers crossed.
Fingers crossed. All right.
Yeah.
Thanks.
Thank you.
Attitude remains nominal during stage 3 burn, and it appears that we have gone over the radio horizon and lost telemetry for the last time on the mission. And this is vehicle on the countdown net. The data that we're seeing now in the center is a simulation of the predicted activities of the vehicle. So although the vehicle is over the horizon and we have no telemetry coverage, this graphic will allow us to continue to watch the expected events as they unfold. Vehicle at this time would be in orbit and preparing for deployment of the 6 SkySat spacecraft.
We are about 2 minutes from the main event, the deployment of the SkySat satellites. With me again is Trina Patterson. So Trina, where are we? Give us a little update on where we are.
So the vehicle has actually traveled over the horizon. So what you are seeing now is simulation. So if you remember from the animation earlier in the show, prior to launch, the first 4 satellites will deploy about 20 seconds from each other. And again, these are the Planet SkySat satellites. And then the vehicle will make that 90-degree turn and release that payload adapter. And that just gets it away from the orbit of the satellite, so there's no collision. And once that's been released away, the vehicle will turn back. And this happens about a minute later. And then those last 2 SkySat satellites are deployed. Approximately just a little over a minute, the 2 Dove satellites are deployed, followed by those last 2.
So in this video, these Dove CubeSats look pretty small. So about how big are they?
They're actually the size of a loaf of bread. They weigh 9 pounds, so they're fairly small. It's amazing what miniaturization of satellites has done to the technology.
So the maneuver that the vehicle does to deploy the satellites, is this common on most launches?